Hello, everyone. So we are going to start the unit Properties of Matter. This is the first section within that unit called Classifying Matter. All right. So the first part that you do need to write down, make sure to write this definition down, is the definition for chemistry. It's the study of the composition, structure, and properties of matter. If you're not sure what the word composition means, it just means what something is made up of. So it's important that you're dealing with what something is made of, the structure, and the properties of that particular matter that you're going to talk about in chemistry. So make sure to write this down. The next question, if you have it, is what is matter? So if I scroll down here, matter is anything that has mass and take up space. So the entire classroom is matter. Anything that has mass and takes up space. So that's matter. Now we're going to expand a little bit regarding matter. Matter falls into two categories: pure substance and a mixture. All right. So let's start with pure substance. Pure substance has two categories within itself: an element, which is on the periodic table that's on the wall. Elements are the elements on the periodic table. I handed out a periodic table to every student in the class. Those are considered elements. It contains one type of particle. So if I look on the periodic table of elements, I can find carbon, hydrogen, sodium, and magnesium. Now, when I combine those elements, so two or more elements combine, that is called a compound. So what we drink, H2O, water, is a compound because it contains hydrogen and oxygen. This element is methane. It contains carbon and hydrogen. All right. And then we have lead 2 sulfate. This is a compound because it has lead, sulfur, and oxygen. So again, an element is a single particle. It's on the periodic table of elements. When you take those elements and combine them, that's where you end up with a compound. So we talked about matter. We talked about pure substances, which is a type of matter. Another type of matter is a mixture. All right. So if you look at the prefixes, homo and hetero, think of this one as the same and this one as different. So when I take elements and compounds and I mix them together, that's when we get a mixture. A homogeneous mixture looks the same throughout. So, for an example, they have vanilla ice cream. It looks uniform throughout, okay? Vanilla ice cream. It's all just one color. Now, if I have cookies and cream ice cream, that is what we call a heterogeneous mixture because you can see the different components that make up the ice cream. So I can see the cookies in there, and then I can see the vanilla ice cream. Another example of a heterogeneous mixture is a salad. All right, so you can see the lettuce, the tomatoes, and anything else that you see within that salad. Now let's scroll down a little bit more. So now we're going to talk about the states of matter. Okay. And if you need to pause this video at any time, make sure that you pause it. So let's start off with solids. There's solids, liquids, and gases. And a lot of you are probably familiar with it, but if not, we still have to go over it. If you look at the spacing, so draw this picture here. All right. So if you want to draw this picture, just make an oval, 2 lines down, and then connect them. That's how you make this beaker. If you look at the circles, the particles, see how they're tightly compacted, they're squished together? That's the spacing in a solid. There's strong forces holding those particles tightly together so that it produces that solid state. It has a definite shape. For example, this is a solid. It has a definite shape, this pen, all right? And it has a definite volume. So stop the video if you need to write anything down. Okay, let's go to liquids. So draw that little beaker again, like I showed you up here. Now, if you notice, the particles have a little bit more space. So instead of strong attractive forces like the solid, we're going to say that the liquid has moderate attractive forces holding it together. It has an indefinite shape. It's not definite, similar to a solid, it's indefinite, which means that if you have a glass of water, you can pour the water into any container and it will hold that shape. So it assumes the shape of the container, a liquid. So that's why we say it's indefinite. So if you want to put a little note that says assumes shape of container, you can. Okay? And then it has a definite volume, a liquid, because I mean, you're not adding any liquid, you're not taking it, the liquid is what it is. So it has a definite volume. The last one is a gas. Draw your beaker, and you'll notice that the particles are far apart. There's weak attractive forces holding them together because they're further apart. They're not attracted to each other as much as the solid up here that is tightly together, the particles. Gases have an indefinite shape similar to liquids because if I put a gas in any size container, it's going to assume the shape of the container. And right here it says takes the shape of the container, takes the shape of the container. I actually realized just now it already has it there. So you don't really have to write this down. The only difference between a gas and a liquid, besides the attractive forces, is the volume. Gases do not have a specific volume. All right. Just like over here, it takes the shape of the container. For the volume, it fills the volume of the container as well. And that is the first page. Let me just flip to see if there's anything else. Yes, there is. So I'm going to go to the back. All right. So at the top, it should say properties and changes. So physical properties, characteristics observed without changing the substance. So for example, I'm observing that this marker is red. The fact that this is red and I observe it doesn't change that it's a red marker. So if you look, color is a physical property. Texture, smell, taste, size. I can taste something and I'm not changing the substance. The size of this pen is always, I'm observing the size of this pen and it's not changing the substance. So those are physical properties. Again, if you need to stop the video, go ahead. Chemical properties. Characteristics observed when a substance changes in composition. So you're creating new substances, you're changing it. So, flammability. Anytime you see anything that involves burning, that is a chemical property because it changes the property of the substance. Reactivity, when you're dealing with chemicals, a lot of times you can create new substances. And toxicity. Okay, I messed up that word. But this also will change the substance. So physical properties is very similar to physical changes. Chemical properties is very similar to chemical changes. With physical properties, the form and shape changes. All right, but you will still have the same substance. All right, so you're going to have the same substance. No new substance is formed. For example, if I rip a piece of paper, it's still paper. That's a physical change. When I take a block of ice, which is water, and I melt it to a liquid, it's still water. So just remember that if you're changing the states of matter, that you are not creating a new substance. All right, that is considered a physical change. So if I have,
excuse the interruption. Can I have Aaliyah Hammer and Sarah Cardona to please come to the main lobby? Thank you.
All right. So if I go from a solid to a liquid to a gas to a liquid to a solid, it's still the same substance. So I'm going to put change. Actually, right here, it has it. Chemical changes, you are creating a new substance. New substance formed. So, cooking food, burning wood, rusting, digestion, decay. This creates a new substance. There are 5 ways to determine if a chemical reaction takes place. So, the word or definition for chemical reaction is one or more substances are changed into a new substance. If you see any of these, a chemical change is taking place. A precipitate is when you take 2 liquids and a solid forms. A solid forms from 2 liquids. So we have color change, there's gas that you see, odor, a solid is formed, and if there's a temperature change, whether it's hot or cold. And the last thing that we have here is these are what we call equations. The left side of the equation is called a reactant. The right side of the equation is called the product. And the arrow is called yield. And it gives you an example here. These are the reactants. It yields or gives us this substance here. And that's it.